So exercise 134, question 11. Draw out this problem. We've got a ship heading with a speed of 20 knots at a bearing of 20 degrees east of south, or south of east rather. And then that's against a current, which is a speed of 4 knots at a bearing of 30 degrees east of north. So I've drawn that on here where I've put in my references of east and north. So now what we need to do is to find the resultant of these two forces and then give that angle as a reference to east. So we again find the vertical and horizontal components of these vectors and then add them together, as similar to what we did in question number 1. So if we look at the vertical components first, now both the forces are going to have vertical and horizontal components. So F1 and F2. So F1 is going to have a vertical component, and so is F2. So for F1, the vertical component is going to be, if I imagine this right angle triangle, and I've drawn a line across here like this, whereas there's the right angle. So the vertical component of the force is going to be this side of the triangle here. So that's the adjacent to the angle. So the cosine is what's involved here. The cosine of 30 equals the adjacent, which is the vertical component of the force, divided by the hypotenuse, which is 4. So FV equals 4 times the cosine of 30. I can do a similar thing for F2. If I look at F2, I'm after the vertical component of the force. So now again, thinking about our convention, this will be a negative force. So the vertical component of the force will be acting down in this way. So again, we can draw a right angle triangle, which is this angle here. And so, to find the vertical component of this force, we're going to need to think about this triangle, which is here. And if this angle here is 20, then this angle too is 20. So that angle is 70. So we can work our way through and find out what the vertical component of the force. We can either use the sine of 20 degrees using this one, and that's the opposite side, or we can use the horizontal, this angle here, which is 70 degrees, and the cosine. But let's use sine, so sine of 20 degrees equals the vertical component, which is negative over 20. So that means that FV equals minus 20 times the sine of 20 degrees. And then we add them together and we get the total vertical component. And we can then do a similar thing to get the horizontal components. Again, F1. So if we look at F1, the horizontal component of the force is the force acting in this direction. So if we take that as our positive by convention, so then now we're after forming this right angle triangle here, and we're after the length of this side, which is going to be the opposite side. If this angle here is measured as 30, because this is angles 30, so is that, then we can find it as the opposite. So it's sine 30. So sine 30 equals the opposite, which is the horizontal component of the forces, over 20. Over 4. So that means that f, the horizontal, is 4 times the sine of 30. And similarly for f2, the horizontal component of the force, so forming the right angle triangle, there we can see that this side here, if this is the angle is 20 degrees, then that's the adjacent side, so it's to do with the cosine. So cosine 20 equals cosine 20 equals the adjacent, which is going to be the horizontal component of the force, over 20 for F2. So F horizontal is 20 times the cosine of 20 degrees. And now I can add, then when I've done that, I can add the two horizontal and two vertical components together and form the triangle. So that will be, horizontal components are going to be this way, vertical components will probably be, well, I'm guessing where that will be, but it'll come out positive or negative, so you'll tell. So we'll have the two horizontal components, the two negative components added together, and then we can find the resultant, which will be this line here. Or if it turns out to be this way, then it'll be in this direction. Work that through and see if you can get the answer in the textbook.